Electronic warfare is the invisible battle unfolding in the air, at sea, and across the spectrum. But how do researchers study it in practice? In this video, we'll break down the keywords of EW, from electronic support, ES, and electronic attack, EA, to decision-making algorithms, and explore the core terminologies you need to know. Coming up in this video, we'll break down these topics. So, let's get started. EW cluster analysis. This colorful network you see on right isn't random. It's built from thousands of academic papers on EW and radar from Scopus database. They looked at the keywords inside those papers and asked, which words appear the most? Which words appear together? The result is this cluster analysis. Each bubble is a keyword. The size of the bubble shows how important or frequent that keyword is. The lines show how often two keywords are connected in research. The colors represent groups, also called clusters, which are themes in EW research. Red cluster, EW battle space. This is about the environment where electronic warfare happens. Keywords include communication, aircraft, UAV, ship, weapon, threat, development. It covers all the platforms, like aircraft, ships, drones, vehicles, and how EW is used in them. Example, protecting a fighter jet from enemy radar using jamming. It also includes threats like missiles or electronic attacks. In short, red cluster equals a battlefield context of EW. Yellow cluster, EW components. This is the hardware and building blocks of EW systems. Keywords, antenna, bandwidth, gigahertz, array, module, amplifier, MMIC, TR module. Let's break them down. Antenna, sends and receives radio waves. Gigahertz, frequency of operation, often very high in EW. Bandwidth, the range of frequencies the system can handle. Array, AESA, antenna arrays like active electronically scanned arrays, which can steer beams electronically. MMIC, monolithic microwave integrated circuit specialized chips for high-frequency signals. TR module, transmit receiver unit that controls both sending and receiving of radar signals. In short, yellow cluster equals hardware technologies that make EW possible. Green cluster, ES algorithms, electronic support. Electronic support is about listening, detecting, and analyzing signals in the environment. Keywords, radar signal, feature, emitter, modulation, recognition rate, neural network, CNN, time frequency analysis. Breaking it down. Radar signal, a pulsar wave sent by radar. Feature, characteristics of that signal, frequency, pulse width, PRI, etc. Emitter, the source of a signal, like an enemy radar. Modulation, how a signal is shaped AM, FM, pulse modulation, etc. Recognition rate, accuracy of identifying the radar or emitter. Neural network or CNN, AI methods used to classify and recognize signals. Time frequency analysis, a technique to study how signal changes over time and frequency. In short, green cluster equals algorithms that detect and identify signals. Blue cluster, EA algorithms, electronic attack. Electronic attack is about jamming and deceiving enemy radars. Keywords, jamming, DRFM, false target, deception, cross-eye jamming, chaff, multi-false targets. Let's explain. Jamming, overpowering the enemy radar by sending strong signals. DRFM, digital radio frequency memory, records enemy radar signals and replays them to create confusion. False target, creating ghost signals so the enemy radar sees targets that don't exist. Range gate pull-off, RGPO, a jamming technique where false targets are slowly pulled away from the real one, tricking the radar into tracking the fake. Cross-eye jamming, tricks radars that use angle measurement. Chaff, small strips of metal released into the air to confuse radar. MFT jamming, multi-false targets flooding the radar with many fake echoes. In short, blue cluster equals the tricks and attacks used in EW. Purple cluster, EW decision-making. This is a brain of EW systems, where artificial intelligence plays a big role. Keywords, decision, strategy, deep reinforcement learning, intelligence, rules. Explanation, decision-making, choosing the best action in real time. For example, whether to jam, deceive, or stay silent. Jamming strategy, picking the most effective technique for the situation. Reinforcement learning, an AI method where systems learn by trial and error, just like training a robot or self-driving car. Cognitive EW, intelligent, adaptive EW that learns from the environment. In short, purple cluster equals AI-driven smart EW systems. Connecting the clusters. So how do all these clusters fit together? The components, yellow, are the hardware foundation. The support algorithms, green, listen to the spectrum and identify threats. The attack algorithms, blue, decide how to jam or deceive. The decision-making cluster, purple, ties it all together, using AI to make smart, real-time choices. And the battle space, red, is a real-world stage where all this happens, across air, sea, land, and space. Conclusion. In summary, this map shows us how electronic warfare is evolving. From basic hardware like antennas and amplifiers to advanced jamming techniques like DRFM and range gate pull-off, and now, towards AI-driven cognitive systems that can sense, decide, and act automatically. The future of EW won't just be about who has the biggest radar or the strongest jammer. It will be about who has the smartest, most adaptive system. That's the next battlefield, intelligent warfare in the electromagnetic spectrum. In reference to research by Reddy and Sinha in their state-of-the-art review, Electronic Warfare Against Radar System confirms that the field is rapidly advancing. They highlight how technologies like AI and next-gen hardware are creating a new era of electronic countermeasures, making it a constant technological arms race. And on a separate note, for any of you curious about how generative tools like OpenAI's ChatGPT are affecting research and content creation itself, including scripts like this one, we've cited that too. It shows how AI is becoming a tool in virtually every domain. Thanks for watching. Don't forget to check the description below for a link to the original research paper. And if you want more content like this, like and subscribe. We're getting into the advanced stuff next, specific EW tech and AI signal recognition. You won't want to miss it. Bye and meet you in next video.